Hello students, welcome to another Algebra 1 lesson. Today I am going to show you how to use everything you know about algebraic properties such as combining like terms and using the distributive property to manipulate your equation so that you'll be able to solve it. Okay, so we're going to use both linear equations and quadratic equations to show you how to do this. Okay. So the first thing we're going to look at is a linear equations. So the most common thing that you usually do in linear equation is to solve for it. So here you have a function that says f of x. So f of x is just another way to write y. Okay. So f of x means y. Okay. It's just a different way for us to write it. Okay. F of x equals to negative 5 times 1 minus 5x plus 5 times negative 8x minus 2 plus 4x plus 8x. So this is a very long expressions over here. Okay, well, when the directions say solve, do you know what it means? You guessed it right. It means let y equal to 0. So in order for me to solve this function for the value of x, I would have to let y equal to 0. But when we let y equal to 0 on the left-hand side, that is simple enough. But look at our right-hand side of the equation. It is such a mess. So we have to clean it up a little bit. And in order to clean this up, we need to use distributive property, combining like terms, and all that kind of stuff. Okay, so we're going to distribute this negative 5 through, this positive 5 through, and combine all the x terms and all the constant terms. So when I do that, I get negative 5 times 1, which is negative 5. Negative 5 times negative 5x will give me positive, 25x. I forgot a 2 here. Negative 20, positive 25x. So I'm going to add that 2 there. And then positive 5 times negative 8x. Be very careful. Positive 5 times negative 8 gives you negative 40x. Okay. And then positive 5 times negative 10 will give me, negative 2 will give me negative 10. And then lastly, the two x terms here, 4x and 8x, I just went ahead and combined and I got 12x. Okay. Now I can further combine this right side of the equation. The left hand side is still equal to 0. The right hand side of the equation, I can go ahead and combine negative 5 and negative 10 to give me negative 15. Okay, and then I'm going to look at all my x's and I'm going to combine them all together. So I have a positive 25x, a negative 40x, and a positive 12x. If I combine all of these together, I would get, so let's say 25x and 12x will give me 37x, positive 37x, and negative 40x will give me negative 3x, okay? Negative 3x, okay, equals to 0. Now this has become a pretty much a one-step equation, okay? So in order to solve this, I need the constant term on the other side of the equation, so I would go in there and I would add 15 to both sides of the equation, okay? I would add 15 over here, and on the other side I would add 15. So it turned out that negative 3x is going to equal to 15. Then to further solve this equation, I would go ahead and divide both sides by negative 3, okay, because I want 1x, okay, so divide by negative 3, and x turned out to be negative 5, okay, so the right hand side is going to become x and the left hand side is negative 5. As you can see, in order to solve this equation, we used a lot of algebraic properties, okay, combining like term, distributive property, and one thing we need to remember always is when the equation asks you, the direction asks you to solve a function, it means let y equal to 0 and then you can find out what x is. Alright, so let's look at another scenario with linear equation. Sometime when you have a function and they ask you to evaluate. Now remember when they ask you to solve, you set x equal to 0. You set y equal to 0. But when they ask you to evaluate, it means that they want you to find y. Okay, so they want you to find y at a certain x value. Okay, so find out what y is. Okay, that means I want you to find the y coordinate of this function when x is equal to 2. So in order to do that, we're going to have to take the value 2 for x and substitute it in wherever we see an x. So we would have to take that 2 and put it there, take this 2 and put it there, take this 2 and put it in there, and then finally take this 2 and put it in there because we have x everywhere. So I would go down here and I would say, okay, I'm going to evaluate this function at, instead of x, I'm going to say at 2. Okay, so that's where I'm going to replace 2 with x. Okay, so now before I do that though, I would rather this equation be simplified first. So for the sake of time, from previous example, this equation, it is the exact same equation that we used on the previous example. It was simplified to negative 5 minus 3. Negative 15 minus 3x. So now we can go ahead and use that to evaluate the value. So I go down here and I rewrite my equation exactly as it appears. And in place of, I'm going to leave a little space in where x is, and in that little space, guess what value is going to go? Well, you guessed it, 2 is going to go there. So I'm going to put 2 in for x. Okay, that means I am evaluating this f of x. Oops, I'm evaluating this f of x at 2. So this whole business about this f of 2 over here is basically another way to say y. Okay, so y is going to equal to whatever this expression turned out to be. So it's going to be negative 15. Okay, minus 3 times 2 is 6, so minus 6. So let's find out what it is. Negative 15 and negative 6 turn out to be negative 21. So when x is equal to 2, in this function, my y value will equal to negative 21. So if you draw this line, this is a linear equation, so if you draw this line, if you graph this line on the graph, you will find the point, the order pair 2, comma, negative 21 on this line, okay, because it is part of this solution. Okay, so basically when they say evaluate, it means substitute x for some value and find out what y is equal to. Okay, now let's shift gear to quadratic equation. Here we have a rather messy quadratic equation simply because it's got the r terms on both sides of the equations and the constant terms on both sides of the equations. So we're going to have to simplify this equation first before we can even think about solving it. Okay, so in order to simplify this equation, I'm going to move everything to one side of the equation. So I'm going to move this negative 3, negative 30, and I'm going to move this positive 11r. And you can do one thing at a time. You don't have to do both of them at the same time. So in order for me to move the positive 11r, I actually end up subtracting it because I want this to zero out. But if I subtract it on the right hand side, I gotta subtract it on the left hand side. And because it is the r term, I would write my subtraction underneath the r term. Okay, I don't want to write it underneath 120. I don't want to write it underneath r squared because this is simply r, not r squared. Okay, so and then I would just simplify that and I'll find out what it equals to. So here my next simplified equation would be 5r squared. Okay, the 5r squared stays the same. However, the r term now gains more negative. So negative 44r and negative 11r turn out to give me negative 55r. Okay, so I would write negative 55r. And then the constant term 120 stays the same. Okay, so I write it down 120. On the right hand side, however, equals 2. On the right hand side, this is already 0 out, so I don't need to worry about the 11. I still have negative 30, so I'm going to write negative 30 down. Okay. The next step, okay, by this time you should know what next step to take, okay? In order for the negative 30 to be on the opposite side, I must add 30 to both sides of the equation, okay? Remember opposite order of opposite operation, okay? Add 30. So as you can see, to move things from one side to the next, okay, using addition or subtraction, they usually become the opposite of what they are. So negative 30 right now on the right hand side, when it goes to the left hand side, it becomes positive 30. Okay, so and that's how it usually works. Okay, once you get the hang of it, you'll understand how these equations work. Okay, so let's take care of the right hand side first because it's easy. Negative 30 and positive 30 is 0. Okay, and then on the right hand side, of course, I have 5r squared. 5r squared minus 55r. Okay, I haven't done anything to that, so I'm just rewriting this. However, the constant term gained 30, so 120 plus 30 is 150. Okay, so now my equation looks a little nicer. Okay, except that it's still large. This is a very large equation for you to try to factor. Okay, so let's see, sometime we can reduce our equation. Maybe reduce is not the right word, but you can simplify your equation. If you notice that each coefficient in your equation is divisible by 5. So 0 is divisible by 5, 150 is divisible by 5, negative 55 is divisible by 5, and 5 is divisible by 5. So if everything in my equation is divisible by 5, I can simplify the whole entire equation by simply divide everything by 5. Now, is that legal? You bet it is, because I am doing the same thing to all of the terms, and I am doing this to both sides of the equations. Now, okay, so what do I end up with? Okay, 5r squared divided by 5 would just leave me r squared, minus 55r divided by 5 would just give me 11r, plus 150 divided by 5 would just give me, I think, 30. Somebody pull out their calculator and see if I'm right. And then the nice thing about the right hand side is we're not even changing anything, because 0 divided by 5 stays 0. Okay, so now our quadratic equation looks like it can be solved using factoring. So I'm going to try to factor this. Okay, now if you guys have forgotten about factoring, I recommend that you watch another video on factoring quadratic equations. Okay, because by this time this lesson is supposed to come after you know how to factor. Okay, so I'm going to factor this equation. To get r squared, I have r times r. To get 30, I got many choices. I got 30 times 1, I got 15 times 2, I get 3 times 10, I got 6 times 5, but I need to consider my middle term. My middle term is 11, so 6 and 5 seems to be good choices to use to get 30, okay? Because 6 and 5 will make 11 somehow, okay? So let's see if it will, okay? I have both negative here because negative 6 times negative 5 will make positive 30, and negative 6 add to negative 5 will make negative 11. So it turned out that my two factors are r minus 6 and r minus 5. So I set each one equal to 0 in order to solve. Remember the zero product property, okay? A times B equal to 0, so A must be 0, or B must be 0. So the first equation turned out to be 6, and the second equation, of course, turned out to be 5 after I'm done solving it. Okay, so this would give me r equals to 5. So there are the two solutions to my quadratic equation. Okay, because it is a quadratic equation, I'm expecting two solutions. Okay, at most. Okay, and these are two distinct solutions. Okay, so on the graph you will see that on the x-axis there will be an x-intercept at 5 and an x-intercept at 6. Okay, I hope you enjoy this lesson. Next time I'm going to show you how to solve rational equations, which is a more complex type of equations. Thank you for watching.